All right, we're doing second derivative, which is, I shouldn't have said that. What does this notation mean, guys? The second derivative. So let's go ahead and on your paper, this is for part C. Let's write down what the derivative equaled. They gave that to us. It's right here, dm dt. So remember, m was the temperature of the milk. You know what? This is a personal preference thing, but what I would do is distribute that 1/4. You can or not, but that's what I would do. If you distribute that 1/4, you're going to get 10 minus 1/4 m. In my opinion, I just feel like that looks a little nicer. There's not parentheses in it. And then we're going to go and do our second derivative. So what's your derivative of just 10?
No, wait.
Oh, it's nothing. Nothing. Good. So that's gone. Let me just cover that up. Derivative of negative 1/4 m is negative 1/4 dm dt, which is negative 1/4 times this stuff. Do you see how that's dm dt? If you feel like, hey, didn't I kind of just write the same thing twice? Bless you. Yeah, I've seen them do this a lot though. So if that happens on your exam, there was one many years ago that was about like a baby bird. It was practically this exact same equation, but dB dt. They do that a lot. So anyway, I think it was a point for that. Let me see. Yeah, you get a point for getting that second derivative. All right. This next part is writing a sentence. I'll go ahead and tell you this sentence is kind of difficult. But again, if you got that point, I'd be happy. All right. It says, where is it here? Use that second derivative to determine whether the approximation we did in the previous one is an underestimate or overestimate of the actual value. What does a second derivative tell you about?
The concavity.
Good. Okay. So you don't have to draw this on your paper, but let me just show you. If it's concave down, like a frowny face, when you have your equation of your line that's tangent, do you see how it's above? All right. Concave up, if you draw in your tangent line, it's underneath, it's below. Okay. So you're going to look at your handy graph here. Do you see how for all of the M's, all the milk temperatures lower than 40, this graph would be concave what? We even drew it in, guys, down. Do you see that? Like a frowny face? Down. Okay. So that would mean concave down means overestimate. So we're going to say overestimate because second derivative, oops, I can't write and talk at the same time, is negative for M's that are smaller than 40, milk temperatures smaller than 40. So the graph is concave down, and it's a point for that sentence. But again, I think that was a hard one, in my opinion. So if you at least got this first point, you got 1 out of the 2, which is, you know, okay. Go ahead. Oh, like if you wrote this? I don't see why not. But I would probably write that. So go with what they did, because that's what it was written in the problem. All right, and then part D, here it is. This is your differential equation. It's going to be on there. They're going to have you do this. Use separation of variables to solve the differential equation. Your initial condition is 0, 5. What you need to do to move the M over is divide this whole thing to the other side. So that is going to be 1 over 40 minus M. You with me? All right, dm equals, and then what's still left on the other side? 1/4 dt. Perfect. All right, antiderivative. Now this would be a U substitution, but I don't want you to write the whole thing out. What is the derivative of 40 minus M?
-1.
-1. So out front, you are just going to need a negative. And then it's ln 40 minus M. If it was a 2M, you would put a 1/2. If it was a 7M, you would put a 1/7. All right. Equals. All right. How about this side? If you changed it to X, they would let it go. We're not done. What else? There we go. All right, it was a point for separating it, a point for doing the antiderivative. You guys have got to be able to do this. All right, then what? Yeah, plug in the initial condition. Time is 0, which is nice because that's just C. And if you plug in 5, this comes out to negative ln 35, which is fine. It's a point for that. Yep, recopy the whole thing. But instead of plus C, put minus ln 35. And then here's where, like, your last point, the 4th point, is gonna come from solving this. The less you write, the better. Here's what I would do. The first thing that has to get divided over is the negative. And I don't like this part of the problem. All the rest of that I'm fine with. I don't like this part. Here's what I would do is erase the negative. And then on the other side, it's gonna become negative 1/4 t plus ln 35. Then what? E. So it's e to the power of all of that. And that's what I want you to do. Don't recopy it. Then what? You're gonna ignore the absolute value. Those are gonna drop at this point. Subtract 40, like that. And you divide by a negative. Now for the last step, I probably would write it out. M equals negative e to the stuff. And then instead of minus 40, plus 40, because you divided by a negative. So that's what your last point is for. I didn't like that. That algebra was wicked. The rest of it I was okay with, but that was horrible. Yeah, good.
How did the ln become positive?
So when we divided by the negative that was out front, I erased it. But the signs changed is what happened. Now, did it add up to 9? Make sure I didn't miss telling you a point. Did it add up to 9? What I showed you? Which of the 9 do you think you would have gotten? Do you think you would have gotten this one?
Yeah.
I hope you would have gotten that one. I hope you would have gotten B. That was worth 2 points.
Yeah.
And then I hope you would have gotten the second derivative. That would be 4. This was actually pretty hard. If you couldn't separate it, you were kind of out for the rest of it. But if you even get 4 out of 9, that's okay. All right, so that's all right.